IEC Industrial Control Schematics, Drawing Layout, Power and Control Sections. In this video, I will use the IEC Example Industrial Control Schematic set and explain the basic layout of the power and control circuits in an IEC diagram. We will start by reviewing or examining the typical IEC schematic page layout. At the bottom of the page, we have our title block that contains all project relevant information. We will be using the page number, which is over on the right hand side of the title block in this little review that we're doing. And IEC schematic diagrams use a page coordinate system, and it may vary depending on the designer. In this case, we have numbers across the top, and we have letters down the side of the drawing. In the case of the page that we're on right now, we're on page 1. We have a red circle placed pretty well center of the page. It is coordinate 1.E7. It's on page 1 and it's located on E7. I will scroll to page 2 now, and we have a circle located at C3, and it gets the coordinate of 2.C3 because it is located on page 2. I will scroll down to the next page. Now we have a circle over at H12. It gets the location of 3.H12, so page 3, H12. I will show you an example of the use of the page coordinate system. I'm on the first page of our schematic set, and I'm looking at a contactor labeled K1. If I go down to the bottom of the page, there is a cross-reference for K1, and it shows that we have contacts at location 2D4, so page 2, D4. So if I look at that, if I go from D to 4, it's referring to these 3 set of contacts. Pretty straightforward for that one. But the coil that energizes those contacts is located on another page. It's located on page 5, H1, and there is another contact on page 5, C2. I will scroll to page 5. And now we can have a look at the coil location. So the coil location is right here. And you can also see the cross-reference location for the coil. And we can also see the contact, which turns out to be an auxiliary holding contact for this circuit, located at C. It's 2 or 3. It's 2, C2, 5C2. So that's an example of using the page coordinate systems to find information about a contactor coil, and auxiliary contacts and power contacts. Another use for the page coordinate system is to identify wires that leave a page and enter onto another page. In this case, we are on page 2, and this is part of the power schematic section. And there are 4 arrows that leave the page, and they show what location they are going onto. This is a fairly straightforward one. They're all going to this basically the same location, 3.A1 for all of these 3, and then 3.B1. So if I scroll down to the next page, you'll notice that those 3 wires plus the neutral, so there's 4 wires, come onto the page in this location. So the location that is shown identifies where those wires came from. I'll show you one more before we move on. So let's look at this power supply. We have a power supply on the far right here. It converts 230 volts AC to 24 volts DC, and then it is distributed through these fuses. If I follow this wire down, let's pick this one. This one is labeled 24V-1. That's the wire label. And it leaves this page and it goes to page 6H3. So let's find out what's going on with that. We'll go down to page 6. H3, so this is H. I'll go over till I hit 3. And it's right here. It's 24V-1. And it cross-references back to the location to where it came from, page 3, I12. And what that is the power for the CPU for the PLC. Now let's look at some basics. We will look at the overall layout of the drawings. I'm on the first page of the schematic set. We have our table of contents, some drawing acronyms, and down below we have wire connections. And we have a legend. So for not connected, meaning that wires are not connected together, if they cross and there is not a dot, it means it's not connected. If they cross and there's a hoop over it, it means it's not connected. If the wires are connected, there will be a dot. In this case, it's a black filled in circle dot. Earth grounds are shown with this symbol, and shielded pairs or conductors that are shielded have a dotted line around it, and that shield is bonded to ground at one end. Down below, we have wire colors listed. This is a standard IEC wire color legend, we'll say. For power wires inside a panel, the three-phase line power in this case, they are black. They are solid black. They also use that in North America for power wires in an industrial control panel. The neutral conductor, if one is present, is light blue. So our neutral is light blue. Red is AC control circuits. We do not have any AC control circuits in this panel, but there are lots of control systems that use AC control circuits. And DC control circuits are blue. So solid blue, dark blue. The protective conductor and bonding wires are green, predominantly with yellow. So they're green and yellow. Now, some basics on the power components. For the most part, they're drawn vertically on the page, but you will see some disconnects and circuit breakers drawn horizontally. Most devices, most field devices that consume current are drawn vertically. In control components, most of the contacts and coils that there are shown here are drawn vertically on the page. Now we'll take a look at the power wiring layout. We're not going to go into a lot of detail as far as wire numbers and devices. We're just looking at the overall layout of the diagram at this point. Typically on an IEC diagram, power comes in on the left-hand side at the top of the page, and it crosses the page, and then it leaves on the far right side of the page. In this case, we have three-phase power, which includes a neutral, and it's called a 5-wire system. It's a three-phase 5-wire system. Notice that the neutral is not broken at all. Okay. So the power is horizontal across the top of the page, and then the devices, the current consuming or power devices, are connected to the bus, and they are situated vertically on the page. So you'll notice that each one of these contactors, K1, K2, K3, and K4, are placed vertically along with their protective devices. So these circuit breakers. Okay, and then we have overloads and then motors on the bottom. If I go to the next page, same layout, power across the top, and then all of the devices. In the case of this inverter, is tapped off the 3-phase power. And then you'll notice that we have single phase devices. So each one of these are heaters. They tap off of one conductor and the neutral. And then at that point, then you can break the neutral through these relays, these heating relay controllers. You'll notice that it's breaking each one of those wires. Okay. And then over on the right, we have a DC power supply that is tapped off of the same bus and the neutral. And that is for our control power. Now we will leave the power section and have a look at the control wiring layout. So the control wiring, we have 2 wires placed horizontally on the page, one on the top and one on the bottom. The wire on the top in this case is 24 volts. It's derived from a fuse circuit on the previous page, and it's supplied from the 24 volt DC power supply. On the bottom of the page, we have our 0 volts DC. And that's on every single page of control, as you can see. Now what I'll do is I'll go back to these DOL circuits. And you've got 24 volts on the top, 0 volts on the bottom. And that'll be helpful to see how these devices are laid out. Now, we have normally closed contact. It is controlled by a motor thermal protection relay, and it's placed vertically on the page. So the initiating devices connect to the hot wire at the top, or the 24 volts. We have a start button, a stop button, and we have a parallel holding contact. And if you follow the wire down all the way down to the bottom, there's a coil, and the coil is connected directly to the 0 volts. We have a light that is in parallel. We have an indicator light, and it's connected to the 0 volts. So all of the loads are at the bottom of the page connected to the 0 volts. All of the switches or initiating devices, normally closed or normally open, are connected to the wire at the top of the page. So they start at the top and they work their way down. And that is the layout for the control circuitry. Now I'll scroll down to the next page and have a look at this PLC diagram. Again, we have our 24 volts on the top and our 0 volts on the bottom. And we have these input devices that connect to all of these inputs on the PLC. And on the bottom of the PLC, we have our output devices. This is very typical in an IEC diagram. So input on the top, output on the bottom, which places all of our output loads connected directly to the 0 volt, just in the DOL drawing I showed you earlier. So this is typical for a PLC. I'll scroll down to the next page. We have an expansion module, so there is no outputs on this unit. There are only inputs. In this case, we only have one input connected. This particular input, for your information, I'll go into this in depth later. It's a through beam sensor, and it requires power to operate. So what you'll notice is it has a wire that connects to the 24 volt, a wire that connects to the 0 volts, and it has an output which gives the signal to the PLC. I'll scroll down a little further. Now we have a specialized module. It's an analog input and output module. It has variable input and output signals, and they are connected to the VFD. We will be covering those in a further video. I'll scroll down to the last page of the control wiring in this schematic. And this is a safety relay or safety monitor. It's a little bit specialized as far as the wiring goes, but you will notice that there are 2 contactor coils that are connected to the 0 volt on the output of the controller. Okay, the power for those is picked up through this wire from the 24 volts, and it's fed through the relay and then out to those expansion relays or contactors. Now, in this case, we have two e-stop buttons, and one set of the contacts from the buttons connects to the 24 volts. And you'll notice that we have two sets of contacts in series, a set for each stop button. And then we have another set of contacts that are connected to the 0 volt for each button, e-stop 1 and e-stop 2. So it's a little bit specialized. It breaks both legs of the power to this unit. I'll go into this in more depth. I'm just going over the drawing layout at this point. In summary, IEC schematics typically contain a power section and a control section. Incoming mains power is drawn across the top of the page from left to right, with loads tapped off the mains and placed vertically below. Control wiring consists of a horizontal wire at the top and bottom of the page. Initiating devices such as switches and contacts are connected to the wire at the top of the page. Pilot control devices such as coils and pilot lights connect to the horizontal wire at the bottom of the page.